Good day, sir. My name is Stefan Duncan, and the title of my capstone project is the feasibility of creating bioplastics in the kitchen environment. Let's begin. The reason I chose this topic was because of its complex but yet simple nature, its many uses, and its unawareness. I hope to close in the gap of knowledge in the Caribbean through the kitchen. So have you ever seen plastic waste like bottles and wrappers laying around on rivers or even roadsides? This is called plastic pollution. What if there was an effective solution to this problem? I introduced bioplastics, which according to ScienceDirect.com is a type of waste made from natural sources like vegetable oil and starch. Uses of bioplastics include packaging. It is also used in the transport industry and even toys. So, what is the problem? The problem statement, as shown, mentions that some bioplastics are better based on its source of starch. To experiment with this, we must ask ourselves, how feasible is it to create bioplastics derived from two starchy vegetables in your kitchen to create biodegradable utensils? Up next will be my goals and objectives. As seen, they are quite similar. Firstly, I would like to successfully create biodegradable plastics from two starch sources. Secondly, I would like to create soup bowls utilizing these completed bioplastics. And finally, I would like to compare sustainability, cost, integrity, and relative water content between these two starch sources. The method for these bioplastics was not as time-consuming but still tedious. For the potato starch, 2 pounds of potato were prepared by grating, after which the grated potato was left in some water for the starch to settle at the bottom of the container. The grated potato was disposed of, leaving the water and the potato starch. The starch was then rinsed until the water became clear. Finally, the starch was left to dry at the bottom of the container for a total of 24 hours. The next day, vinegar, glycerin, and water were combined with the starch in a small pot over medium heat until bubbles start to form after vigorous turning. After which, lay the mixture over a small bowl covering every inch. After 7 days, remove the plastic carefully and proceed to the 24-hour water absorption test. For the cassava starch method, it was quite similar to the previous potato starch method, with the only exception of blending the cassava. This ensures the breaking of the amylose chains of the vegetable, so all of the starch is released. For the results section, this table was created showing significant features to be compared between the two starch sources used. So there is solubility, structure and texture, preparation time in minutes, cost in dollars, dry time in days, integrity, and finally relative water content in grams. Relative water content was seen as the best comparative feature and therefore it was showcased with the formula used and on which bowls. To better understand this table, we must go through the 24-hour water absorption test. This was done by inserting all the bowls in 2 liters of water where it was left for 24 hours, after which the wet weight was calculated as seen. For the relative water content, the formula was wet weight minus dry weight over dry weight, as seen in the table here. Still within the results section is the student's test of the relative water content. This was done by having both a null and alternative hypothesis. As seen, the null hypothesis mentions there is no significant difference in water content between both starch sources. However, the alternative hypothesis mentions that potato starch is better and absorbs less water. However, through the help of Excel, we can see that the p-value was more than a significant value, which meant that we accept the null hypothesis, which meant that there is no significant difference in the water content of both starch types. On to the discussion section. From the table in the results section, we see that solubility, structure, and integrity all test the strength, elongation, and water absorption of the experiments. For cassava, the plastic was partially soluble after the 24-hour water absorption test. This makes sense as the structure of the plastic was quite thin and flat after creation. The table mentions that the plastic was also punctured very easily. This shows that the cassava-based plastic was quite poor in performance and weak within the experiments. On the contrary, the potato-based plastic was recorded as insoluble, somewhat rigid for structure, and only had punctures after a week of creation. This shows that even if features were not as expected, the potato-based experiments were stronger. For cost and preparation time, cassava revealed $15 per container with 10 minutes of preparation time, while potato reported just $2 more with $17 for cost and the same 10 minutes for preparation time. As we can see, not much of a significance. The same could be said for the relative water content through the t-test mentioned earlier. In conclusion, you may ask yourself, which bioplastic is better based on its starch source? Comparing structure, relative water content, and integrity. Throughout this presentation, it has been shown how bioplastics were defined, made, and even used. But which starch source is better, potato or cassava? Through the results section, we could see that there were no significant difference between most of the features. However, when comparing just structure, the potato starch performed much better with the plastic holding the shape of the bowl very well. Potato starch also took a shorter time to dry and stayed intact longer compared to the cassava type. So to answer your question, this will make the potato starch a better starch out of the two. For the references list, only one reference was used to define bioplastics, which was written by Saeed in 2016 entitled Introduction to Bioplastic Engineering. And finally, for my acknowledgements, I would like to express my sincerest gratitude to my supervising lecturer, Dr. Farrell, for his timely feedback and clarification on this project. Secondly, I would also like to thank my friend Nashon Smart for assistance in selecting this bioplastic topic. And finally, I would also like to show my appreciation to my demonstrator, Shaima Mohammed, for encouragement and reassurance in my progress reports. I thank you all for your concern and wholehearted assistance.